Right. So Ammar Rahimi. Ammar Rahimi. Tak ada pula. Dah masuk kelas tak ada. Aber Chan. Aber Chan. Aber Chan. Qayyim. Qayyim.
Ya, sir.
Tolong baca soalan.
Question 2A.
Yeah.
PI and PD controllers are used to improve the performance of a system. Give the general transfer function of each controllers and state the performance that can be improved by those controllers.
Okay, sambung. Continue.
B. The root locus for the closed loop system in figure Q2A is shown in figure Q2B. The system operates at a damping ratio of 0.5. Determine the open loop transfer function of the system and estimate the controller gain K, the settling time, the peak time, and the steady state area for the system.
Right. Sambung.
3 is it is important for the system to have a zero steady state error while keeping the system to operate at the same overshoot. It is possible to design a controller to replace the proportional gain controller K so that this specification is satisfied. Prove your answer. And the fourth one is draw the component of the system block diagram including the controller with the value of each proportional gain KP. Integral gain Ki or derivative gain Kd obtained, depending on your proposed controller.
Right, so Q2B is given, plot is given. Okay. So straight away, question 2A is a direct question. You have to give the transfer functions of the PI and PD controller. Okay. So let's go. So okay. PI PI controller. So GPI is equal to KP. Dia ada gain S plus XC. Dia ada zeros, one zeros, and there is one pulse at the origin. So this one will make ESS equal to 0. So ZC is very close to the origin. Okay, 0.01, 0.5, 0.05. PD is GPD. Okay, GPD is equal to KD S plus ZC. Okay, so this one is faster, transient. Okay, so ZC we have to calculate from the given root locus. Okay, so that is part 1. Part 2, so the root locus for the closed loop is in figure Q2A. Okay, in Q2B, right? So the system is operate at damping ratio zeta. Oops, sorry. Okay. 0. Okay. So determine the open loop transfer function of the system. So let's go to the plot. Boleh kecilkan tak? Tangan saya boleh kecil tapi dia tak boleh kecil kat sini. Kalau tengok dekat situ, apakah pulse dia? Ni kan? Minus 6.
Negative 6.
Ni minus 8 zeros kan? Yang ini minus 1 plus minus J plus minus J 1. Betul? Senyap je. Halo?
Betul.
Betul. Senyap je.
Betul.
Tak saya seorang-seorang ni. Takut saya. Okay. So, dia punya open loop will become? Open loop transfer function will become?
S plus 8.
K dulu. K, gain kan?
Okay.
S plus 8. Zeros kan?
Hmm.
Then S plus 6 kan? Poles. Then ada complex conjugate poles. Complex conjugate poles tu.
S plus 1.
S plus 1. S square plus 2S plus 2 kan?
Hmm.
How I get this? This one is you just plus 1 plus J1 multiplied by S
Times.
plus 1 minus J1 kan? So, you dapat yang
Betul ke?
betul. Ingat senang nak ajar online ni. Tak apa.
Betul ke?
Okay. So that is the open loop transfer function, and then closed loop transfer function. Closed loop transfer function is just you ambil
Over
1 plus K.
closed loop transfer function. K S
K.
plus
plus 8 over
S plus 6.
square plus 2S plus 2 plus
plus S
plus
plus K plus 8.
kan? So given,
Yes.
given damping ratio 0.5 kan? So dia punya theta berapa? Theta dia. Tadi terputus pula. Theta dia is cos
60.
inverse cos
60
0.5. Berapa ni? Setengah? 60?
60.
60 darjah. Tak payahlah. You don't have to press calculator lah kan. Biasa budak uni ni kalau inverse cos ke 0.5 tekan calculator macam tak pro lah. Dia semua dah ada dalam memori tu, dalam RAM. Jangan ketawa. Nanti kau tekan calculator. Okay. Then you draw the straight line approximation kan. Dia punya tu. Apa nama ni?
Dari dominant pole.
Ya betul. Jadi ni dah contoh.
1 times.
Jadi kita kena padam. Padam pakai tangan. Okey, saya padam pakai tangan pakai jari. Nampak? Nampak. Hebat betul kan? iPad Pro tu yang I suka betul pakai iPad Pro ni.
Hebat tu, hebat.
Lepas tu kan kau dah padam kamera ni. Tangan kau tak merah kan? Dekat finger ni tak ada warna red color.
Magic.
Dia jangan jealous. Ini cikgu dia pakai. Anak murid dengar. Okay. So 60 degrees kan? Jadi
Yes.
nanti kalau online aku pun tak tahulah macam mana nak buat. Kau ambil lah protector tu kan. Letak dekat kosong tu, dekat origin tu. Lepas tu kau tolak lah dia ni. Zoom tu.
Approximate sir.
Approximate
60.
Kemana kan? Darurat.
Boleh kata dua ke? Dua.
Yelah, 2 pun boleh. Okay. Titik ni
Saya
berapa?
letak protector ni sir.
Awak dah print kan benda tu? Berapa awak dapat?
Dah.
Syarida. Suhaida. Syaridi.
Ada sir, syuhada.
Syuhada.
Sekejap saja.
Syuhada ni kira mati syahid kan? Berapa? Dia punya dominant pole tu. -1 plus J 1.6. Macam mana Pro dapat? Ini daripada skema. Ini daripada skema kan. Nanti you measure lah, dapatlah -1 plus J 1.6. Itu adalah dia punya apa? What do you call that?
Saya dapat J2.
Sorry. Dia punya dominant pole.
Dominant pole.
Dominant pole kan. Ini dah sudah. Dia suruh cari gain K. Settling time, peak time, steady state error. Macam mana tu? Jadi tadi dah dapat -1 apa tadi? -1 plus apa tadi?
1.6.
1.6.
1.6 ke 1.6.
Ya. So real -1
Negative 1.
ING
1.6.
kan?
Use
Oh.
TS.
Jadi K ni kamu kena kira K ni pakai gain criteria L1. Okay. K ni kan adalah 0.6. Kira sendirilah. Kena pakai masuk online pakai pembaris lah. Ataupun kira pakai trigo. Jangan pakai pembaris. Pakai trigo.
Sir, kalau pakai calculator boleh tak, Sir?
Boleh. Calculator tu pakai trigo lah. Tak dengar suara. Please, kuat sikit kau punya tu. Mikrofon tak kuat. Okay, so the answer will be K 1.14. Kalau tak dapat salin tak apa. Ada dalam YouTube, jangan risau. Dan settling time, ingat, this one you must remember lah. Gitu. 4 divided by 4 seconds. Peak time. Fine. IMG, imaginary
Absolute sir.
Modulus, mesti modulus. Sebab kalau dia
Modulus.
negatif jadi positif. Kalau dia positif jadi positif. Mesti modulus.
Okay.
1.96 seconds. Okay. Jadi yang tadi tu, yang K ni, sebenarnya dia adalah KP sebenarnya. Proportional gain. Proportional gain. Maknanya dalam reality dia adalah variable resistance. Kan? Kita duk putar tu kan. Dia punya knob dia tu, KP lah tu. Jadi sekarang ni, error dia macam mana? Error. What is the relationship between ES and KP? Apa hubungan kulit antara ESS and KP? The correlation
1 over
between
1 plus
ESS and
KP.
So ESS is equal to 1 over 1 plus KP. Kan? P tadi adalah 1.14 kan?
0.4.
Tekan calculator. Aziz Alia, tekan calculator please. Berapa nilai dia? Steady state ni? Aziz Alia. Tak datang. Syakira? Member dia? Pun tak datang. Siapa yang ada situ?
0.47.
0.47. Bagus. Okay. 0.47. Ada soalan?
Tak ada.
This one is
Sir,
about
can you
0.5.
return to the way how to calculate the KP?
Actually, KP ni, kalau kita lihat the formula dia ni kan. Some books refer KP as the K that we calculate just now, okay? But if you're using a formula, another formula, you will get the same answer as well, which is more or less the same lah. Which is a KP limit S to 0 kan? K, okay. So KP is equal to 1.14, the gain that we calculate just now, S plus 8, okay. S plus 6, S squared plus 2S plus 2, okay. So the best thing is using this formula, okay. KP is equal to this, so KP is 0.76, okay. And then USS is equal to 1 plus 0.76 0.568. So you use this formula. Okay. Yang just now ni cancel. Alah. Alah Don't use this one. Okay, use this one. This one is true. This one is lagi accurate compared to the we assume K as the rule of case as a KP. Next question is it is important for the system to have a zero steady state error while keeping the system to operate at the same overshoot. It is possible to design a controller to replace the proportional gain so that this spec is satisfied. Prove your answer. So maknanya, what do you understand from this part 3? The question asks how to replace the P controller with the good one that can reduce steady state error to 0. So you use a PI controller. Okay, use a PI controller. So meaning that yes, using PI. Okay. Yes, using PI. So GPI can choose any number, 0.1, the smallest one. Okay. Then you multiply GPI with the open loop transfer functions. S plus 6 S squared minus 3S. Okay. Then this is the new overall transfer function with the PI controller. And again, you have to calculate the gain, the key, which is the L1, L2, L3, and L4, and L5, and L6. Okay. So what is L1, L2, L3, and L4? L1 is due to this one is the force 1 over S. L2 is because of -1. Okay, 1 over +1. L3 is because of the this one is okay. L3 is because of the 1 over S plus 1. Okay, so L2 is because of the you have to check. Okay, because for this, so you have 2 zeros. Okay, 2 zeros, S plus 0.1, S plus 8. That's why this one is 0.1 and 0.8. Okay, zeros. It's only because of the poles. Okay, which is 0, S plus 6, minus 6, and -1 plus minus 0. Okay, and the K is equal to 1.14. Okay, so L1, L2, L3, L4, L5, and L6 use trigonometry in order to find the value of K. Okay, so draw your, and 0 steady state error. So you have to prove, we have to prove that the steady state error is equal to 0. So therefore, okay, ESS is equal to 1 over 1 plus KP. Okay. KP is equal to limit S to 0. Okay. K GPI in G. So KP is equal to limit S to 0, 1.14, S plus 0.1, S plus 0.8, S plus 6, and s squared plus 2s plus. So you insert the 0 inside, then Kp is equal to infinity. Okay, so therefore ESS is equal to 1 plus infinity. So you prove that after using Pi, the steady state error is 0. Very long question. Very long question. Draw the complete compensated system block diagram, including the controller, with the value of each proportional gain Kp, integral gain Ki, or derivative gain Kd, obtained depending on your proposed controller. So we are using a Pi controller. Okay, so therefore, if you want to draw the block diagram, so you have to write again the GPI, okay, which is Kp S plus Zc over S. Okay, this one is Kp S plus 0.1 over S. Okay, so GPI 1.14 S plus Ki over Kp, all divided by S. Okay, so Ki over Kp, the ratio, okay, which is Zc, is equal to 0.1. So that's why Ki is equal to 1.14 multiplied by 0.1. Okay, so Ki is equal to 0.114. Okay, 114, and Kp is already calculated just now, 1.14. So the total block diagram of the controller will be like this. Okay, positive. Okay, 1.14 Kp. Okay, G, then feedback here. And this is the reference. Okay, and Pi is over here, goes here. Okay, 0.114. Okay, so this is what I call a Pi controller. Okay, so is there any questions? Any questions?
Prof, can you return to the steps that found out the closed dominant poles one?
Okay, oh, that is in the graph. Okay, this one. Okay, so you have to find the 60 degrees, then draw the straight line from the origin. Okay, 60 degrees. Okay, then we will cross here. -1 plus minus j 1.6. So that is the dominant pole.
Okay.
Okay. So during online, you have to be creative lah. Either you print out, okay, or you use your creativity lah in order to draw this, okay. Or probably maybe the dominant pole is given, okay. So to make life easy, kan, because once you measure by your own, so if there is a 57 students, so there will be 57 different dominant poles. Okay, but the range must be between this one. Okay. So this is what they call our revision for the test one. Okay. There's so many things here. So we already finished this one. Okay, so we have this one for tomorrow. 12 o'clock, okay? Tomorrow, 12 p.m.
Okay.
Hello.
Yeah.
And maybe also can tomorrow, 12 p.m. And then test 1, 13, 14 will be on Monday, 11 p.m. Okay? Monday, 11 p.m. So this is what I plan. Okay? For test 1. Then I will blend with the frequency response questions from the test 2. I will forward to you. Okay? So most probably, according to the coordinator, okay, if I'm not mistaken, this is the latest. It's on the 11 graphic. Okay, right? Test 1, 11 e-learning. Have you done any test in e-learning before?
Yes.
So there is a password, and then there is a time constraint, maybe 1.5 hours. Then after 1.5 hours, you have to scan PDF, okay, or CAM scanner, and then upload into the e-learning. Then I will mark from there, okay.
Prof,
Any question? Yeah. Hong Chiu?
does the tuning method come out in final?
Most probably no. Most probably no. But I have to check again, okay. But
Okay.
we will discuss final exam past year question nanti during the discussion. We will give you some ideas, what to study, what not to study, and so on. But for sure, PID and neglect is not in because it's too long. The solution is too long. Okay. For assignment, okay. For assignment, because we give plenty time to the student to solve the problems. Any questions so far? This
Doktor,
is yeah. Hello. Fahmi?
boleh tanya soalan chapter 3 atau?
Chapter 3. Chapter 3. Chapter 3. Boleh? Silakan.
Saya nak tanya kena buka slide.
Kita buka slide. Slide tu ada tak? Can you share with us?
Oh, mak, saya guna handphone dulu tu. Macam mana nak share?
Handphone. Guna handphone. Can you snap the picture and send to the WhatsApp?
Okay.
We wait for the question from Fahmi. Meanwhile, is there any question? We have about 9 minutes online.
Sir,
Ya.
saya nak tanya yang soalan 1 tadi sir.
Soalan 1.
Yang soalan last tu,
Kuat sikit.
yang soalan last tu,
Ya.
jawapan kita 5 tepat sir. Boleh kira second order?
Okay. Kalau 5 tepat, dia macam ni. The ratio kan. Ratio kan. Ratio is greater than 5 or less than 5. Okay. So the one that you get is greater than is as equal to 5. All right. So equal to 5 is considered as this one, greater than 5. So this one is 4, 3, 2, 1, 4.5, 4.9 is considered as purely second order. Okay, so above 5, 5 and above, consider as approximate second order valid. 5 and above. Okay, 5 and above meaning greater than 5. Itu. Okay.
Oh, okay sir.
4.9 tak boleh. 4.9, 4.99. No. There is no second order approximation. Question,
Okay,
Fahmi?
sir. Thank you.
Fahmi,
Oh, saya dah set up.
Okay.
Master.
Fahmi send a question. So, what is the question?
Kan dia suruh cari K untuk gain 22 dB.
Uh-huh.
Yang 52 minus 22 tu. Saya nak tanya 52 tu dapat from mana?
52.
Minus
52 is
22.
from the gain margin before gain adjustment.
How to know?
By marking on the board diagram, the gain margin of 22 decibel corresponds to a phase angle minority. It is possible to calculate the lift required. And again, which is 20 log K is 52 minus 22. Is the 52. Ada dalam tu. Ada dalam notes tu. Can you refer the 52 tu? Ada nombor dia dekat depan tu. Sekejap. Tak nampak lah kat the notes, saya payah sikit. Stop share. Okay, so saya share di chapter 3
Chapter 3.
Chapter 3. Chapter 3.
Chapter 3, slide number 105, tutorial 3.
105. Ini ke? Ni nampak? Ni ke? Slide number?
105.
Oh, belakang lagi. 105. Oh, jauhnya. One zero five. 105.
Question 3. Ada masa?
Nampak? So 105. Okay. Yang ni ke?
Sekejap.
Hmm.
Tutorial 3, question 3.
Oh, tutorial 3. Tutorial 3. Question. Aduh.
3.
Alright. Okay. Ni.
This one.
The value for K gain margin 22 decibel. Okay. So the target is 22 decibel. Jadi kita kena kira berapakah dia punya phase margin dia. Phase margin dia is 108. Kan? 108 dB before gain adjustment. Okay. Before gain adjustment. So by marking on the board diagram, the gain margin 22 decibels corresponding to phase angle minus 180 is equal to 100. It's possible to gain the value required. So what is the gain at 100 radian per second? What is the gain margin? 100 radian per second.
100.
Radian per second dekat board diagram ni. Yeah. 100. 100 di sini. Tak nampak kan? So lebih kurang kat sini lah, lebih kurang 52 dekat graf ni. It's about 52. So that's why the what do you call that? The difference between the 52 and 22 is the amount of shift yang kita perlukan, iaitu 30 decibels. Dia sebenarnya dia tengok the original gain margin tu sebelum compensation. Kan? Kemudian dia kira punya gain margin, then they find the difference of the target. Target is 22. So therefore you kena cari 52 minus 22 equal to 30. Tapi dalam plot ni tak berapa tepat. Okay. But if given in the Excel, so you can see that this 52. 52 you assume as the gain margin before compensation.
Oh, maksudnya 52 tu before.
Before gain compensations. 22 ni after. Jadi beza dia tu adalah 30 yang kita kena shift the gain curve up. I will discuss
But
it again. Sorry?
But tapi yang gain margin bukan 108.
Itu sebab dia scale dia besar. Scale dia besar. Sebenarnya kalau kita kecilkan lagi graf ni, it will become 52.
Oh, okay.
Scaling ni besar. Lepas tu nampak 108. Dekat frekuensi ni. Kalau kita baca ayat tu, by marking on the board diagram, the gain margin 22 decibel occurred, okay, dekat phase angle minus 180, which is 100 radian per second. So kita perlu lift required, the gain is about 30 decibels.
Means that gain margin before minus dengan dia punya gain margin after.
Yes, that's true.
Okay.
Okay, masa tinggal 1 minit lagi. Any questions? Tak ada? Okay, kalau tak ada, so we stop here. Ada satu chat sini. Apa dia nak chat ni? Okay, sir. Okay. So, see you tomorrow, 12 PM. Boleh? Hello? See you 12 PM.
Yes.
Thank you.